Understand the relationship between intermolecular forces, IMFs, and equilibrium vapor pressure. Vapor pressure is a measure of the pressure exerted by a gas in equilibrium with its liquid phase. The ease with which molecules escape from the liquid surface into the vapor state is inversely related to the strength of the attractions holding them together. Liquids with weaker overall IMFs have a higher vapor pressure because fewer energy barriers exist to prevent molecules from escaping into the gas phase. Analyze the symmetry and polarity of the transisomer. In the transisomer, the chlorine atoms are positioned on opposite sides of the carbon-carbon double bond. The individual carbon-chlorine, C-Cl, bond dipoles are polar and equal in magnitude, but because they point in geometrically opposite directions, they cancel each other out completely. As a result, the transisomer has a net molecular dipole moment of 0 and is nonpolar, meaning it experiences only London dispersion forces in the liquid state. Analyze the symmetry and polarity of the cis isomer. In the cis isomer, the chlorine atoms are on the same side of the double bond. This asymmetrical distribution means that the individual polar bond dipoles do not cancel each other out, giving the molecule a net molecular dipole moment. Consequently, the cis isomer experiences dipole-dipole interactions in addition to London dispersion forces. Compare the overall IMF strengths of the two isomers. Because both molecules are isomers, they share the same molecular formula and molar mass, giving them nearly identical London dispersion force strengths. However, the cis isomer has the additional, stronger attraction of permanent dipole-dipole forces, which makes its overall IMF stronger than those of the trans isomer. Determine which isomer has the higher vapor pressure. Because the trans isomer is held together only by weaker London dispersion forces, its molecules can easily escape the surface of the liquid compared to those of the cis isomer. Therefore, the trans isomer has the higher equilibrium vapor pressure at 20 degrees Celsius. This matches option D. The correct answer is option D, the trans isomer, because it has only London dispersion forces, whereas the cis isomer also has dipole-dipole interactions.